Good evening, everyone. Rajkot and Beat. बाकी सब कहाँ है? Anyways, so welcome to the second class of AC circuits, right? You have studied and came. सब revision करके आए, नहीं करा है, so just take out the notes, whatever you have, and continue from there. Okay. So today, बच्चों, we will be completing this chapter. Okay. We will be completing this chapter completely. And then you can practice questions. Next, in the next upcoming weekend, you will be having the test. Okay, so there was no test this week. Okay, so let's start. Let's start with Newton's first law. Anna? Sir, how in AC circuits Newton's first law came? Just for knowledge. You remember Newton's first law? What is Newton's first law? Think. कुछ याद आ रहा है? 11th class. So Newton gave three laws, right? The first law is which you prefer to do, correct? है ना? Sunday को maybe or Saturday को you people will be doing not waking up in the morning. So a body at rest wants to stay at rest, correct? Okay. So on this note, let's start by not following the Newton's first law. Okay, let's move ourselves. Let's put some stress on our brain and end our day by learning some good things and completing the chapter as well. Okay. So in the previous class, I gave you this as homework. Can you tell me the answer? Answer batao. Rajkot, Beat, and YouTube wale people also. What is the answer? Agra, Bombay, China, Delhi. What is the answer? तुम लोगों ने किया है? You people have done this? Or just simply came in the class? Think. Okay. Chalo, so let's see what will be the answer. Okay. So in a circuit consisting of a capacitance and a generator, means capacitor in AC circuit, with alternating EMF E naught is equal to EGO, means it was E naught actually, generator ka naught. Sin omega t, VC and IC are the voltages of the current. Correct phasor diagram for the circuit is. So bachcho, I have told you, remember this word, inductor, ब्रैकेट में L. इंडक्टर मतलब करंट and L मतलब lag. So current lags in inductor means current will lead in capacitors. Okay. So if current is leading in capacitor, then voltage, let's see which option has the leading current. Okay. So first option, current is clockwise, omega t lagging. B option, current is in phase with V, voltage. C option, current is anti-clockwise leading from voltage. So C option is absolutely correct. And here current is in opposite phase to voltage. Not possible. Okay. Simple question. Chalo, so today let's start a series LCR circuit. Okay. And in series LCR circuit, basically resistance is connected, inductor is connected, and capacitor is connected, right? Current will be passing from here, going in this first resistance, then inductor, then capacitor. Acha, the current which is passing or coming out of this source let's say it's I. So the same current I will be flowing in resistance also, the same current will be flowing in inductor also, and the same current will be flowing in capacitor also, hai na? These are the markings, not the wires. Okay. So let's say VR is the voltage drop on resistance, VL is the voltage drop on inductor, and VC is the voltage drop on capacitor. Okay. So LCR circuit, this is a series LCR circuit. Parallel LCR circuit is not asked much. Okay. Very less questions, means the possibility is very less in case of parallel LCR. That's why we are not taking that topic also. We will be studying only series LCR circuit, right? Chalo. So series LCR, acha, along with the this what I'm teaching, please note it, okay, so that I can move a bit fast for you people, right? Chalo. So if I talk about series LCR circuit, just a second. Okay. So if I talk about series LCR circuit, where that went, I think one slide is missing. No problem. Chalo. So in series LCR circuit, bachcho, if I talk about the resistance, or if I talk about the voltage across resistance, so here is the voltage across resistance, let's say, okay, on x-axis. So current across resistance will be in the phase of resistance, voltage across resistance. So I made the phasor of resistance. Now, if I talk about inductor, in inductor, the current is lagging than voltage, right? So current is here, current is lagging than voltage, means the voltage of inductor, bachcho, will be little bit up, pi by 2 leading, pi by 2 leading voltage of inductor. Satisfied? So this is the voltage of inductor and current is lagging by pi by 2. Similarly, if I talk about capacitor, in case of capacitor, the current is leading. That means voltage will be here. We can write voltage is pi by 2 lagging than current. So this is the phasor diagram. Okay. And the frequency is omega. Now, if I talk about the resistance and the impedances or the reactances, then how I will draw the diagram? Look here, all of you. Okay, so along with this understanding, you please note also very important things are going on. Okay. So if I talk about the resistance, so resistance will also be in the same phase as of voltage. Similarly, in the inductor, the reactance will be in the same phase as of voltage. Similarly, for capacitance also XC. Okay. Chalo. Now, if I want the net impedance, but if I want the net impedance, net Z, then for net Z, let's say if XL is greater than XC, okay, means this quantity is greater than the XC, then I can say the diagram will look somewhat like this. Upside, the net value, which will be XL minus XC, and on the right side will be the resistance. So I can calculate the net impedance, which will be the resultant of these two vectors, that is net impedance Z, and let's say this is phi. Okay. Chalo. So phi, I will tell you later what is phi. Okay. Phi is the angle between the impedance and the phi is the basically phi is cos phi is called power factor, right? That also I'll explain you. Don't worry about it. If I talk about the second case, if XL is less than XC, then sometimes this also diagram is possible. Okay, but the resultant will be approximately same. So XC minus XL are, if I talk about the resultant will be somewhat like this. Okay, we can shift the vectors now, bachcho. We can shift this vector XC minus XL. This will be the resultant, that will be Z. Okay, and this will be phi. Here also shifting of vectors. Okay, chalo. So in this way, we can find the resultant impedance. Okay, so since the impedance Z is formed in this triangle, we can use Pythagoras. So we can say R square plus XL minus XC का whole square का under root is equal to Z. Simple. So here also, if people see the same thing I have written here. Array camera, okay. The same thing I have written here, right? Z is equal to resultant R square plus XL minus XC का whole square का under root, right? And what is tan phi? Tan phi is XL minus XC, that is perpendicular upon base, right? Clear? Please note it quickly. Note it. Those who have not noted back page, look at the back page also. So voltage of resistance, voltage on inductor and voltage on capacitor with the current. Okay. Chalo, let's move forward then. Okay. So here, sorry, solution is already mentioned. Huh? Okay. We'll leave it. Chalo. So read the question quickly. Till then I will do some beautification. Read the question. You don't have to solve, I'll solve it. Okay. Read the question. So this question came in JEE Mains 2017. In this type of questions, what we have to do, we have to write all the things, whatever is there in the question. Okay. Chalo. So let's read the question. Huh? I hope you have read at least once. So it is telling there is a sinusoidal voltage of peak value 283 volts. Means V0 is given as 283 volts. Then angular frequency means omega is given 320 radian per second is applied to LCR. LCR circuit is there. Given that R is equal to 5 ohm. So R is given as 5. L is given as 25 millihenry, means 25 into 10 to the power minus 2 Henry. Sorry, minus 3 Henry. Then capacitor is also given as 1000 microfarad, means 1000 into 10 to the power minus 6 farad. The total impedance, so we have to find Z impedance. Okay. And we have to find the phase difference, that is phi. Right? So these two things we have to calculate. Okay. Easily we can calculate by using this data only. Right? Chalu karte hain. So if I talk about Z net is equal to under root of R square plus XL minus XC ka whole square. So we want XL and XC. Already we have R. So if I calculate XL, which is omega L, omega is 320, inductance is 25 into 10 to the power minus 3. So this will be 25 by 1000, right? Which will be 40, 1 by 40. 25 by 100 is 1 by 4. So 25 by 1000 is 1 by 40. So if I cancel here and I can write here 40. So this gets cancelled out and it is 8 ohms. Similarly, if I calculate XC, so it is 1 upon omega C, and 1 upon omega is 320. Capacitance is 1000 microfarad, means 1000 into 10 to the power minus 6, means 10 to the power minus 3. Means on numerator it will go 1000. Okay. So if I calculate, this will be 100 by 32. Let's write it as 25 by 8 ohms. Clear? So we got XL, we got XC. Now we can calculate the impedance. So R square, 5 square plus, I'll just switch off the video so that you can see the full question. So, okay, so 5 square plus XL. What is XL? Not the size of the shirt. XL is inductive reactance, which is 8 ohms. 8 minus 25 by 8 का whole square का under root. Okay. So with magic, I will find the answer. So it will be 20, nahi, it will be root 50, that is 5 root 2. Okay. Or approximately we can write it as 7 ohms. Clear? So B में मुझे दिख रहा है, B and C I can see 7 ohms, but still phase we have not calculated. So we can calculate the phase as well. Hold on. Okay, so tan phi is equal to, do you remember, XL minus XC upon R ka mod? Because anything can be greater. XL can be greater, XC can be greater, right? So if I put the values, XL minus XC, that is 8 minus 25 by 8. Okay, so 8 minus 25 by 8 divided by resistance is 5. So this is approximately 64 minus 25, or we can say 3, 8 minus 3 is 5, 5 by 5, approximately 1 you will get. Okay, so phi approximately I can say is 45 degrees. Clear? So both answers we got, bachcho, right? So 45 and 7 is option B. I hope this is clear, right? Let's move then. Chalo, we have to study a lot, huh? That's why I'm going a bit fast. Next question. Please read the question, 20 seconds. Quick. And you can also try. If you have confidence, you try. Oh, late people are also coming. Silvasa Gondia. Arey, come on time. You will miss something, then you will say, sir have not taught and sir is going in air. Sir is going like a bullet train. Okay. And don't worry, I will show my beautiful face, but I have off the camera so that you can see the full question. Okay. Chalo, let's read then. Very simple. You will not do, I will do. Listen here, all of you. In an LCR series circuit, an inductor, write all the data, whatever it is saying. Inductor is 30 millihenry, 30 into 10 to the power minus 3 Henry, and a resistor of 1 ohms are connected to an AC source of angular frequency omega is equal to 300 radians per second. The value of capacitance for which we have to calculate capacitance. The current leads the voltage by 45, means phi is given as 45. And it is saying current is leading. In inductor, you remember? Inductor, L, inductor is current, L is lag. So current is lagging in inductor. But here it is saying current leads the voltage. Means it is not an inductor, it is a capacitance. Right? Capacitor is high. Means I can say XC is greater than XL. Okay? चलो इसको बाद में डिस्कस करेंगे. Right? चलो. So it is asking what is the value of capacitance. Very easy question, you know. So we can write 10 phi is equal to XL minus XC by R ka mod. So 10 45, phi is 45, okay. XL, बच्चों XL is omega L. Omega is 300 and L is 30 into 10 to the power minus 3. Omega L minus 1 upon omega C. C is given as, not given, we have to calculate. So I'll write C divided by R. R is, had I missed something? No. R is 1 ohm. Okay. So it will be 1 is equal to minus 3 says 0, 0, 0. So it will be 9 minus 1 by 300 C. Okay. So from here C I can write as 9 minus 1 is 8. 8 by 300. Okay. Is it correct? Had I done some mistake? Oh, देखो. Listen, what it is telling? Here it is telling current leads the voltage. Means who is dominating? Capacitor. Means I can say XC is greater than XL. So I will write XC minus XL. Okay. Here I have written XL minus XC. Now I'll just exchange it. So XC minus XL. Okay. Similarly, here also I will attach a negative in front. So this will be minus. Okay. Chalo. So we can write here C is equal to 9 plus 1 is 10. 10 by 300. Okay. I think it is correct now. Okay. Okay. So from here, if I solve it, I'll get 1 by 30. But the answer is in this form, 1 by x into 10 to the power minus 3. So I have to extract from here 10 to the power minus 3. So if I extract 10 to the power minus 3 from here, if I extract 10 to the power minus 3 from here, so I can write 1 by 3 into 10 to the power minus 1. Let me check the answer. Somewhere I think a small mistake is done. You also check. I'll also check. Let's both check. Okay, omega is correct here, 300. C is also, sorry, omega L. L is also correct here, 30 into 10 to the power minus millihenry. Okay. Minus 1 upon omega C. Omega is 300 C by resistance. Resistance is 1 ohm, correct? This is 1. Oh, this was the mistake. Okay. So here a bit calculation mistake. I'll recorrect it. So it will be 1 by 300 into 10. Okay. So it will be 1 by 3 into 10 to the power minus 3. This is the capacitance. So if I compare here, so X ka value will be 3. Clear? Abhay, tell me, is it clear or not in the chat? Quick. Small mathematical mistake was there, which I corrected. Is it clear? Yes or no? Please type in the chat. Then we will move forward. Reply. Somebody sit on that computer nearby. Whenever I ask you, at least reply. Only Rajkot is replying. YouTube wale. Chalo. Next, let's start electric resonance. Very important topic. Question definitely comes. Okay. And it is also favorite topic of JEE Advanced. So in resonance, something they will do. So what is the meaning of resonance? I'll tell. Okay. Resonance means whenever two quantities are perfect for each other, that basically is the resonance, right? For example, let's say my hand is moving like this. Okay. My hand is moving like this. Now, if another hand comes and if that hand is also moving like this, so I can say both the frequencies are matching. And down se step ban gaya, right? Both the frequencies are matching means they are in resonance. Okay. Jaisa ye, waisa ye. That is resonance. Okay. So electric resonance happen in RLC circuit. It can happen in LC circuit also, which is called LC oscillations. And the condition for resonance is the reactances become same. The inductive reactance and the capacitive reactance will be equal. So XL equals to XC, sorry. XL equals to XC. So if I put the value of XL, that is omega L, and XC, that is 1 by omega C, I'll get some omega that I'll calculate later on. So what is the benefit of resonance? Okay, sir, why we are studying resonance? Why we are doing XL equals to XC? Listen carefully. Whenever you do XL equals to XC, this component which is of impedance gets cancelled out. Only resistance is remaining. If this was also there, then in resistance, it would have added and it would have increased the impedance. If impedance increases, current decreases. So we can in other language also say, if I want maximum current in LCR circuit, resonance condition should be there. Okay. So when resonance happens, XL equals to XC. So this component gone to 0. Only resistance is remaining, means impedance is nothing but resistance. So circuit behaves like a purely resistive circuit. Even though inductor and capacitors are there, even though in their presence also, they are not effective. That is the condition of resonance. And in resonance condition, you will get maximum current because current is equal to voltage upon impedance. Impedance decreased because XL equals to XC. So current will be increasing and it will be maximum, right? So in resonance, current is maximum in a circuit. Okay. So by practical means also I'll explain you. Okay. Dhyan se sunna, that story of radio also I'll tell you. Okay. Because in radio, resonance happened. You have seen radio? Nowadays we have mobile phones and all. But before, let's say 10 years, mostly people used to hear songs on radio. Radio was famous. Today also radio is famous, but it is like online available. That big radio comes na, that radio, have you seen? It has some channels of frequency. 93.7 FM. Suno life banao, something like that, Radio Mirchi. Okay. So in that also resonance happens. I'll tell you how. First, let's solve that equation XL equals to XC. So if I solve that XL equals to XC, XL minus XC is 0 and Z is minimum, means current is maximum. So XL equals to XC, omega L equals to 1 upon omega C. From here we get omega is equal to 1 by root LC. And this omega is called angular frequency of resonance. Okay. Or frequency for maximum current in a circuit. Right. So from here, if omega is equal to 2 pi f, then we can get frequency also for resonance, 1 upon 2 pi under root LC. So please note it, the condition for resonance as well as this equation, very important. Chalo. So only less time is there. I'll quickly sum up. So I'll tell you the story of radio. Basically what happens in radio, there is a knob. Okay. If you have seen that radio, then you are very fortunate. If you have not seen, search somewhere and use it. So if you turn that knob, in radio also LCR circuit is there. Okay. So if you turn that knob, something sound will come. And some buzzy sound will come. Like this sound will come. This sound, what is this sound? This is the sound of changing of capacitance. When you change that knob, the capacitor in the radio changes. When that capacitor in the radio changes, it will be having some frequency at every time when the capacitor changes, right? Means the circuit will have a frequency, angular frequency, right? For example, if I talk, let's say, I don't know what is radio Mirchi. I'll just take a random value. Let's say 90. Let's say there is a radio of 93.2 FM. Means this is a frequency, 93.2 hertz is the frequency. And this is the frequency which is coming from the tower. Okay. This is the frequency which is coming from the radio tower. It is transmitting. And your radio is also here. This has a knob and a slider is also there. Okay. From where you can note the frequencies and all. and a speaker grill is also there. Okay, so this is your radio. You are turning the knob, and when your radio also, the circuit in the radio, if it also has 93.2 FM, sorry, 2 hertz frequency, by turning that knob of capacitor, these frequencies will match. And when these frequencies will match, what will happen? Resonance will happen. And in resonance, maximum current flows. And you can hear the song. Okay. Whatever song, Honey Sing song or whatever song is playing in 93.2 FM, that you can see, that you can hear very clearly. If you still turn that knob, if you disturb that knob, the sound will be buzzy or some change will be there, not clear sound. But on a particular point, that is resonance frequency, the sound will be maximum good because maximum current is flowing. This is the condition of resonance. Now what happened? You changed that frequency. Now you cannot hear the sound. So look at this graph. Actually, this graph is depicting everything. So this is omega on x-axis, on y-axis current. When is the current maximum? On condition of resonance. And there is a frequency which is omega naught, which is called resonant frequency. So this is the condition when you achieved that maximum current, and now you can hear that song very nicely. If you increase the frequency by turning that knob, now the current will decrease and the sound of the song will also be buzzy, or it will decrease, or it will not be proper. If you decrease also, then also it will decrease and it will not be proper. Clear? Now, let's say, in this, the current will be given by E is equal E upon R square plus XC, XL minus XC ka whole square. Same. And if I talk about the frequency, here is the resonant frequency. If I decrease the frequency, means if frequency is less than resonant frequency, means this quantity, on resonance condition, these two are equal. But if you decrease the frequency, look here, all of you, if you decrease the frequency, here frequency in denominator will decrease, totally it will increase, and this will decrease. Means who is dominating? XC is dominating when frequency is less than resonant frequency, means in this case, in this area. So who is dominating in this area? Capacitor. That's why I've written XC is greater than XL. Similarly, if I increase the frequency than resonant frequency, on resonant frequency, these two were equal. If I increase the frequency, means this denominator increased, means whole value decreased, means this also increased. So this increased, this decreased, means who is dominating? Inductor. That's why I've written XL is greater than XC in the second region. And on this region, both are equal. XL equals to XC. So that also I'll write here, XL equals to XC. I hope you understood, right? Now what happened? You also thought that, okay, I will also open my radio channel. Okay, I also want to broadcast my favorite song list. So you went to the radio wala and you told that I went to some Pandit, some Jyotishi, and that Jyotishi told me that your frequency should be 93.5. You told that radio wala, I want 93.5 frequency, right? But the radio wala told, if you keep this frequency, already there is a channel near to this frequency. Then you will argue, no. But that channel is 93.2 FM, right? But we are taking 93.5. What is the problem? He will say, if you keep the frequency near to that frequency, for example, in your frequency, some Honey Sing song is playing. Okay. Let's say Dope Shop. Okay. And in this frequency, some news is going on. Okay. So aaj ke mukhya samachar aise, something is going on. So let's say this frequency, this one is the frequency of 93.2, and let's say 93.5 is here. This is 93.5. Now you can see that here also the current is I0, and here also approximately it will be Imax. This is Imax, and here also approximately will be Imax only, approximately near about. So in both channels, the current is flowing approximately same. Means you will hear some two sounds. Aaj ke mukhya samachar, Navina Dope Shop, aaj ke mukhya samachar, something like that mixed up. And that is called signal mixing. Okay. So that should not happen. For that, what is decided ki you should choose a frequency such that the power is halved and the current is decreased by root 2. Okay, so for other channel, this person will be guided ki, Arey, no, you cannot keep 93.2. Keep a frequency in which the power of this frequency is at least halved. Okay, so look here. Acha, power is halved means somewhere here it will be. Okay, so there is a frequency, or there is a frequency range in which this signal is only alone and no other signals will be coming. That is called bandwidth. Okay, I'll tell you. So to avoid channel mixing, gap should be given such that power becomes half. Okay, so if power is half, power is equal to I square R. Power is directly proportional to I square. So if power is halved, means I will become by root 2. That's why current should flow 1 I by root 2. That much range or that much bandwidth should be there. For I by root 2, there will be a corresponding frequency, right? So look here. So what is bandwidth? Bandwidth is the region in which the power, or the region corresponding, this bandwidth is the difference of the frequencies, on which the power is halved and the current is by root 2, 1 by root 2 times. Okay, so in this range, if you keep any other signal, it will be called channel mixing. That's why out of this range only the channels are kept. For example, here the frequency was 93.2. Here is 91.2. Here is 95.2. So that person or I have to select a channel which is having higher than 95.2 or lesser than 91.2. Then only my channel will be played nicely. Okay, no channel mixing will be there. I hope you understood bandwidth. I tried my best to explain you. So please note whatever you want from here. So this is power by 2, I naught by root 2, power by 2, I naught by root 2. So there will be two corresponding frequencies, and the difference of these two corresponding frequencies is called bandwidth. Okay? Are you understood? Understood, bachcho? Let's move forward. So we have to complete transformer also. Jaldi se karte hain. So quality factor. What is quality factor? Acha, this frequency on which resonance happen is called resonate frequency. Okay. So quality factor is a parameter which will tell the sharpness of that curve. Okay. So resonate frequency upon bandwidth is called quality factor. If you decrease the bandwidth, the quality factor will increase. Means if you decrease this gap, अच्छा इस gap को कम करेंगे, so it will become more sharp. Correct? If you decrease the gap, it will become more sharp. If you more decrease, it will become more sharp, right? So sharpness is decided by quality factor, and quality factor is resonant frequency, which is, let's say, omega naught divided by omega 1 minus omega 2. This is also the formula of quality factor, XL by R. Okay, derivation is not required. So XL by R is equal to resonant frequency upon bandwidth. What is resonant frequency? It is 1 by root LC that we have already found. XL is omega L and bandwidth is omega 1 minus omega 2. Let's do a question then. Okay, look here. Read the question with me. A series LCR circuit consisting of 5 Henry inductor, means L is 5 Henry, 8 microfarad capacitor. So capacitance is 8 into 10 to the power minus 3 farad, and 40 watt resistor. 40 ohm it may should be. Just a second. Okay. It is 40 ohm. Okay, 40 ohm. 40 ohm. So resistance is 40 ohms. Is connected to 230 volt variable frequency. So voltage is 230 volts. The angular frequencies of the source at which power transfer to the circuit half the power at the resonant angular frequency are likely to be. So it is telling कि you have to find the angular frequencies, means you have to find omega 1 and omega 2 for which the power transferred to the circuit is half the power at the resonant angular frequency. Do you remember what I taught you? Half the power. Okay, where the power halves? Here, where the current becomes I by root 2. Okay, so basically it is asking the bandwidth frequencies, right? Chalo. So options are also given. Look here. So if I want to find bandwidth, but just now I told you the formula. Look here. This is the formula. We will use this. So resonate frequency upon bandwidth is equal to XL by R. Okay. Now, what is the resonate frequency? Resonate frequency. What is the resonate frequency? Let's say it is omega naught. Bandwidth is bandwidth only. XL is omega naught L and R is R. So omega naught gets cancelled out. From here, bandwidth you will get as R by L. Bacho, R is 40, L is 5. So 8 is the bandwidth. Means I can say omega 1 minus omega 2 is equal to 8. See the options which has a difference of 8. First option nahi hai. Second option 25 50 ka difference. Third option bhi nahi hai. Fourth option yes. Clear? Chalo. Let's move forward then. Okay. Now let's come to power dissipation and power factor. So power of a complete cycle is half V naught into I naught into cos phi. Okay, is half V naught into I naught into cos pi, where V naught and I naught are the maximum or peak voltages and current. If I want RMS, then I will just divide this 2 into 2 parts, root 2 root 2. So V naught by root 2, I naught by root 2 cos pi, and V naught by root 2 is VRMS, I naught by root 2 is IRMS, and cos phi is cos phi. Cos phi is called power factor, right? So if cos phi can vary from -1 to +1. Okay. Now power factor basically is a factor which will determine the power. If let's say the value is 0.5 cos phi ka, then the power will be half V into I by 2. If it is 0.75, then power will be 3 by 4 into VRMS, IRMS. So it is a factor which will vary the power average power. Okay. And cos phi is equal to R by Z. Okay. Tan phi, do you remember? Tan phi was XL minus XC by R. Cos phi is R by Z. So important formulas, please note it quick. Chalo. So if I talk about resistive circuit, the power factor will be R by Z. Z in case of purely resistive circuit is only R, because XL and XC are not there, because capacitor and inductor are not there. So power factor for resistive circuit is 1. Okay. Power factor for capacitive circuit is 0, because there is only C. Okay, there is no R. So R will become 0. So 0 upon XC is 0. Similarly, 0 upon XL is 0. So power factor for inductive circuit is also, purely inductive circuit is also 0. Okay. So which is better power factor? If power factor is close to 1, then the circuit is more better. Okay. Chalo. So now let's come to the last topic, transformer. So we'll study transformer and eddy currents, then chapter is done. Okay, quickly let's complete it. Kitna time bacha hai? 10 minute bache hai. Let's do it quickly. So transformer, what is transformer? You have seen some people call it as DP also. Okay, I don't know why. Okay, not display picture. DP bolte hain ki DP blast ho gaya, DP fat gaya, something like that. So transformer, various types of transformer are I have put here. So I think you have seen this transformer, right? Ye wala dekha hoga, and this also you people have seen. I think this also you have seen, this also you have seen, this also you have seen, this also is. This is not easily visible, and this also. Okay, so these are all the types of transformers. What is the work of transformer? By transformer is a device which converts the AC power into AC power only, but by varying the voltage. Okay, so for example, if I talk about charger, okay, so here is this charger. Inside it there is a transformer. That's why the current which is coming in my room is AC current, but my laptop is charging with DC current. So this will convert the AC into DC? No, that is called rectifier. Okay, it will also lower the voltage. There are two things in this. One is rectifier, one is transformer. Rectifier will change AC current to DC current. Okay, but before changing it to DC, there will be a device which is called transformer fitted in this charger, which will take the power. Actually, this voltage which is coming in our houses is 230 volts, approximately 220 to 230 volts. So in two phase wiring, single phase wiring. So 230 volts ko my laptop will take only 30 watts, or let's say 15 to 30 volts it will take max to max. So this transformer which is fitted in this charger will convert 230 volts to 20 or 30 volts, how much my laptop is requiring. Okay, so that's why called power adapter. Okay, okay, it is put back. So transformer is a device which can decrease the voltage. Also it can do ulta, it can also increase the voltage. If it decreases the voltage, it is called step down transformer. If it increases the voltage, it is called step up transformer. There are two windings in transformer. One is called primary, one is called secondary. Okay, so what is the statement written here? Device used to transfer electric energy from one AC circuit to another, one or more other circuits, either increasing or reducing the voltage. Okay, so here is the transformer diagram. Okay, so there are two coils. One is called primary, one is called secondary. ठीक, secondary coil किसको कहते हैं? The coil which is connected to the load, bulb, AC, something. Primary coil is the supply voltage coil, from where the supply is coming. So from this primary coil, coil, some flux is coming out. Okay, so there will be a flux, and since it is an AC current, when current will be positive, flux will be flowing, let's say, in clockwise. When current is a negative cycle, flux will be flowing anti-clockwise. Means flux is changing continuously. If flux is changing continuously, means there will be some induced EMF in this coil. Okay, so it is a topic of EMI only, extended version of EMI only. So from here, the flux is created and it will induce a current in the secondary coil. In this way, transformer works. So current in the primary coil is IP, secondary coil is IS, voltage in primary VP, voltage in secondary VS, number of turns in primary NP, number of turns in secondary is NS, right? What is the efficiency? Efficiency is always output upon input. If I eat 20 calories and if I work 10 calories, what is my efficiency? 10 by 20, output upon input, that is 50%. Okay. Similarly, transformer also has efficiency. If it consumed some power, let's say 10 watt, and it gave only power 8 watts, what is the efficiency? Output 8 upon input 10. So 8 by 10, 0.8 is the, or 80% is the efficiency. So what is efficiency of transformer? Output power upon input power. Okay, output power is voltage into current. So it is VS upon IS. Means here is the output, secondary coil per output hai. So secondary coil ka current and secondary coil ka voltage divided by primary coil voltage and primary coil current will give you efficiency. Okay, now if I say I have an ideal transformer, which is practically not possible. Ideal transformer will, let's say, if takes 10 watts, it will give 10 watts. Means there is no losses. Okay, in the transformer. Loss means this, you can see now, this is called iron core. It is made up of iron. Okay, this is called iron core, right? And when flux is induced in this iron core, there are some heat losses. It will become hot. Okay, so ideal transformer mein there is no heat losses, let's say, which is practically not possible, but for calculation we are assuming. So if ideal transformer, then efficiency is 1 or 100%. Okay. So one more formula you need to know. So if efficiency is 100%, then VSIS, that is power output upon power input, will be equal to 1. So from here, I can say VS upon VP is equal to IP upon IS. Means just taking this IP here, IS here, I have written this formula. Similarly, VS upon VP means secondary voltage upon primary voltage is equal to secondary loops, number of loops or number of circular wiring upon number of loops in primary coil. Okay, turns basically we can call. So this is very important. Please note it. Please note this page quickly. 30 seconds. Okay, chalo. Chalo, let's do some questions before then we will study eddy currents and then quickly we'll end up the class. So it is telling there is a step down transformer, means voltage is decreasing. So I will make a small transformer. This is primary coil. This is secondary coil. So connected to an AC main. So here 220 volts is there. Okay. And is made to operate at 11 volt. So there is 11 volt and 44 watt. This is power. Okay. Ignoring power losses means it is an ideal transformer. Ideal transformer. Okay. So jitna power on the right side, utna power on the left side. So here also 44 watt. Okay. What is the current in the primary circuit? So it is asking what is the primary current. Okay. So I know the formula. Number of primary turns upon number of secondary turns is equal to voltage primary upon voltage secondary is equal to current secondary upon current primary. Current ulta hota hai, right? So we can use this one, right? So if I want to calculate the current in the first coil, I can say it is power is equal to VI. Okay, I'll just off this. Power is equal to VI, right? So this is the primary power is 44 watt, which is equal to voltage primary, that is 220 into current primary. Thik? Similarly, if I equate it with on the right side, because both have the same powers, so I can say voltage secondary, that is 11 volt into current secondary, right? Voltage secondary into current secondary. So we can either find primary or we can find secondary directly also. So question it is asking what is the current in the primary circuit, right? So what is the current in the primary circuit? Either you can say that power 44 upon 220 is the current in primary circuit, or from here also you can find. Okay, secondary mein kitna current hoga? Power upon voltage, that is 44 upon 11, that is 4. You can put this value here as 4 and you can get IP, or you can directly get IP from here. So IP will be approximately 0.2 amperes. Calculation is your part, right? So 0.2. B option is correct. Chalo, let's move forward. This is your homework question. This is your homework question. Acha, I will put the homework question at the end. Let me explain quickly eddy currents. What are eddy currents? So whenever flux is induced in this iron core, this is called core, iron core on which the turnings are there, or this coil is wounded. These currents, these magnetic flux or this change in magnetic flux will also induce current in this iron core. Those are called eddy currents, right? So eddy currents are the current loops formed over conductor surfaces due to changing magnetic flux. Okay, what is the use of it? They are sometimes useful in induction heating, levitating, electromagnetic damping, and electromagnetic braking. These are the uses, but here in transformer, it will create heat losses. Okay, so they can be minimized by adding slots in the conductor surface or laminating. Means for reducing eddy currents, this is laminated like this. Layers are put, and in between those layers, some inductors are, some non-conducting material is put. Okay. So here you can see the eddy currents. Look here. This type of eddy currents happen in the core. Okay. And to remove this eddy currents, this sheets are used to make the iron core, and between the sheets some insulators are kept. Okay. Chalo. So here also the core of transformer is laminated. Laminated means layers are put because energy losses due to eddy currents may be minimized. B is the correct option. Okay. So here we end up this chapter. You can take this question as homework. Please note the question quick. Now it is your work to practice. My work is done. If you have any doubt, you can ask me quick. Answer I'll tell you in next class. Okay. Chale. Shall we end the class? That's it for today's class. If you have any doubt, you can ask. No doubt, bachcho. Very intelligent. Huh. Chalo, we'll discuss in the next class. Okay, about this question, and then we'll start ray optics. Okay, very interesting topic. Chalo. So bye bye all of you, and have an awesome dinner. We'll meet in the next class.